Definite integral study guide answer key. Here's our first problem, the integral from 1 to 2 of 1 over x squared dx. This is not ready to be anti-derived, so we're going to need to rewrite this as the integral from 1 to 2 of x to the negative 2 dx. Now that we've done that, we can perform the fundamental theorem of calculus. So we have our antiderivative, which is x to the negative 1 over negative 1, and we are evaluating this from x equals 1 to x equals 2. We have to plug 1 and 2 into x, not the most pleasant of values to plug in. So let's rewrite this as the, we can break this x down to the denominator, and whether we divide by negative 1 or negative 1 divided by, it doesn't matter, the negative sign can go anywhere. Out front, up top, down below. We just need one negative sign because of that negative right there. Again, evaluated from 1 to 2. So we're looking at negative 1 over 2, that's our f of b, minus, and now we have negative 1 over 1, that's our f of a. Double negative there means that we're adding, so we're looking at negative 1/2 plus 1, our answer is C. Number 2, using the substitution u equals the square root of x, the integral from 1 to 4 of e to the square root of x over the square root of x dx is equal to which of the following? Okay, well let's do this. U is equal to the square root of x. That's the same thing as x to the 1/2. Therefore, du is equal to 1/2 x to the negative 1/2 dx. Well, we don't see anything with negative exponents in our integrand, so we're going to need to rewrite this again. This will be 1 over 2. There's our 1/2 right here, just moving right there. X to the negative 1/2 becomes x to the positive 1/2 when we move it down into the denominator, just like we did for problem number 1. And we also don't want x to the half, we want its equivalent, which is the square root of x. So du is the same thing as 1 over 2 square root of x dx. Well, let's go back and look at our problem. We have the over square root of x and dx, those are taken care of. The ones up there, it's just not written. The one thing we are missing is the 2. We need a 2 down there. If we put a 2 in our denominator, we need a 2 in our numerator out front to counterbalance. So what are we looking at? Slide this down here. We have the 2 out front, and then our integral. Ignore the balance for a second. Instead of e to the square root of x, since the square root of x is u, we'll have e to the u. And then the dx, the 2 and the square root of x, which are in the denominator, those are the same as du. So they all go out, du comes in. So there needs to be a 2 out front. That eliminates d and e. The question is, what are the new bounds? We have to plug our old bounds into the u equals the square root of x equation. So if x is 1, u is equal to the square root of 1, which is obviously 1. If x is 4, then u is equal to the square root of 4, which is 2. So our answer, once again, is C. Okay. Problem number 3. We have the integral from 0 to 3 of the square root of x plus 1, except it's been written as x plus 1 to the 1/2. So it's ready to be anti-derived. If we look at this, u is equal to x plus 1, du is equal to dx. So we don't actually have to use u substitution here. We can. If we do use u substitution, we would have to change the bounds. We can just leave it as b. All right. This is going to become, actually I'll do it over here. We have x plus 1. We have to raise the exponent up once, so that's going to be 3/2. Right? 1/2 plus 1 is 3/2. And we divide by 3/2. It's evaluated from 0 to 3. This is rather difficult to plug in 0 and 3, so let's rewrite this. All right, so we have dividing by 3/2 is the same thing as multiplying by 2/3. And then we have x plus 1 to the 3/2 power. That is the square root of x plus 1 cubed. We remember from our algebra class. We're still being evaluated from 0 to 3. Move down here. So we perform our fundamental theorem of calculus. We're going to plug 3 in first. That's our f of b, minus, now we plug in 0. So when we plug in 3, we have 2/3, and then we have the square root of 3 plus 1, or 4 cubed. And then we subtract Now we plug in the 0. Be careful, this will not be 0. This is one of the times when plugging in 0 does not produce a 0. We still have our 2/3, and we have the square root. 0 plus 1 is 1, so we have 1 cubed underneath our square root. Alright, none of those answers look like any of these, so we got to rework this. 4 cubed, 4 times 4 times 4 is 64. So we have 2/3 times the square root of 64 minus 2/3 times the square root of 1. The square root of 64 is 8, so we have 2 times 8, or 16 over 3, minus 2/3. Now we see our answer is D.